Well, here we are, week 12 of cis204 Unix shell scripting and utilities. And this week, if I can get back to where I should be, let's see here. How about this? We're going to finally, after all this time, and I find myself there. After all this time, we're going to talk about building shells. Now, we built a couple of shells earlier, one of the earlier projects, and it was a throwaway. It was a cheap, simple shell where you were doing gathering disk space information. But the notion is that shell scripting is something you end up doing, and in particular, it's to install products. It's to do one-off type operations that can be done easier using shell scripting than building a complete compiled program for it. So the trick is shell scripts can be used for just about anything. They can be used for very small items that you need to do on a regular basis, or it can be done with the one-offs, as we said. Shell scripts can be huge. I've seen shell scripts that run multiple pages, and at some point we'll take a look at one of those as we go forward here. But regardless, your Project 6 is basically a big shell script. Everything up to this point has been kind of straightforward, single type tools, sed, awk, grep, learning the command structures, and now basically we'll put some of those together using bash greps. So bash shells. I want to do a quick little review of week 12. You'll see the syntax here looks somewhat like regular C syntax, but there's a while loop, a for loop, break and continue loops. The break loop is basically you reach a particular point and you get out of the shell. You break out of that loop basically and continue processing, or you exit. And then the next was you skip something and move to the next. And again, the notion is that I can show you that I have 11 fingers, say 4 after every finger. Anyhow. There was a break statement allows you to break out of the loop. So basically, if x is equal to 20, then I break. I print an iteration. And the fun thing is this break statement doesn't require any file to process because it sets x equal to 1, while 1, it prints the iteration. If x is equal to 20, then it breaks, else it just increments x. And since all it's doing is incrementing x, it just keeps working until it reaches 20. So the continue statement again will match a condition, then continue on to the next line. So again, this idea was you set x equal to 1, and while x is less than or equal to 10, if x equals 5, you increment x and continue, else you print the value of x, and then increment x. So it will print 1, value of 1, the value of x is 1, increment x to 2, come back through, value of x is 2, increment it to 3, come back through, value of x is 3, increment it to 4, come back through, value of x is 4, increment it to 5. It reaches that if x equal 5, it increments x to 6, continues, comes back through, it's not 5, so it's going to print the value of x as 6, and so on. Okay, fairly straightforward. The other thing we did was we created an index for an array, and this was part of your solution to Project 5. The array name string is equal to a value. The array name is the name of the array. The string is the index of an array. So, for instance, number is $2. The array name is number. The index is the string found in field 2. The value is not set to anything other than the string. The other thing that has to be remembered about arrays is arrays collect unique elements only. So if it sees the once and sees it again, it will only store the element the once, even though it's occurred more than once. And that leads us to the notion that what you need to do, if you want to keep track of how many of those have occurred, is to do the plus plus at the end, and that will keep account of the number of times that element occurred. Now, when we get to class, we'll grab some week 13 files, but for what we're doing, we're going to start dealing with text in shell scripts first. Echo is a command that can be used to display text in scripts, and very often you'll use an echo Department of Redundancy department, for instance, for the Project 6, and then do a read. Well, there's also a command that allows you to do read -p hello. Now, if we could type, I'd be dangerous. Hello. We'll do this. And we'll see what we get. How's this? Hello, Bob. And it worked. It did what you said. So, echo $name, right? Bob. So what I did here is I read input from the user, but I also used the -p option for read to print the hello. Typed hello and put Bob in, echo name. So if I wanted to do this, echo, please enter your first name, right? Okay. And then immediately after, read name, Tom, because I'm in a Tom kind of mood. So echo $name, right? There it is. Okay, that works. Now you can see there's a couple of different ways to accomplish that read. One is to run the print to begin with. How could I have done that echo and picked up Tom on the same line as the please enter? Well, would you believe an echo -n. Roger. Echo $name. That poor name keeps getting reset. Okay. Printf also works on the command line to display text and can be used in scripts. I really like printf because printf allows you to set up parameters for the text strings. Print, however, works inside of specific scripting languages, and for our purposes, you really want to avoid it in shell scripts. Now, remember that echo automatically adds a new line character. The way you suppress it is, as we have seen before, is to put the -n in there. Printf does not automatically display a new line. So the fun thing is, if I type this, print, enter your first name, error, no such file. Okay. If I do this, printf, enter your first name, well, if I could type first name, space that, and we're going to read name, Tom again, echo $name, right? There it is. So printf, of course, didn't spit a new line. But what if I do this? There it goes. Echo $name. Okay, so that works. Printf is basically print formatted. It's defined by a POSIX standard, and the print commands have been around basically in compiled programming languages since the beginning of time, or time in this sense, printing. Printf does allow a much greater control of formatting output than does print. So if I want to really look at what's going on here, let's take a look at core utilities, printf. Let's clean this up and do this. Ooh, there it is. Core utilities, node, printf invocation. Next, yes invocation. Print previous, echo invocation. So 15.2 printf, format, print data. Printf does formatted printing of text. Printf prints a format string, interpreting the % directives, and escapes to format numeric and string arguments in a way that is mostly similar to the cprintf function. Heavily emphasize mostly in the mostly similar. Note, printf format directives, libc output conversion, the differences are listed below. So this will give you some place to go if you want to take a look at the differences here. Pretty straightforward. It's out there. You can look at it. You can go through it. And you'll learn more about printf than you want to. So let's move forward. How do you format printf? Well, printf is format strings and arguments. The % tells the command that you are about to specify a format. So two common formats and ones that you'll use on a regular basis are S for string and D for decimal, F for floating points. So let's take a look at this wk13 shell here. Let's go over to Johnson County Community College here. Get that input. Okay. Oh, lots of shells in there. So let's take a look at this vi printf.shell. There it is. So here's a quick primer on how to format variables in printf. So I'm going to export I equal 4 and export x equal 2 and export product equal 2. So if I do $I divided by $x equals product, that's a printf. If I do a printf $I divided by $x equals $product, that works. But let's see what we get out of this thing. So there's this printf. I've got this goofy way of looking at this information. So printf, there's the substitute the variable, $I. There's the text because it's red. There's another variable, $x, and there's another variable, $product. But notice how all of these variables are surrounded. They're surrounded in single quotes. And the whole form of printf is surrounded in single quotes. The escape n at the end is basically there to tell printf to print a new line. So printf.shell, right? 4 divided by 2 equals 2. Is there another way to do that? Well, there could be. Now, if we go forward a bit here, here's some examples of a signed integer 5 places long with a decimal precision of 2 digits. Well, that really should be a float. How about this? 25 character left justified, which is what the dash in front of the 25 means, string, padded with white space if necessary. This is why printf works so well with formatting reports. You can specify the maximum length of a string, and it will format the output so that all of those characters are used. It pads with white space, so you don't get the jumble of stuff floating around that you would using print and having to go in and insert tabs in various places afterwards, after the fact. So printf allows you to format a field to the longest known string that will be in that field, and yet it will preserve the format even when there's only 3 or 4 characters in the string. So that works. Now, you can also do exponentiation. In this case, 6 floating point 6 places with decimal precision of 4 digits and exponentiation. So that'll work. Now, how do we program the bash shell? Well, it's the shebang. This is also the magic number, and it tells the kernel what program should be used to interpret the script. The script is run non-interactively by default. It just runs. It does not ask for user interaction on its own. Now, bits and pieces inside that will allow you to run. And I say interactively, even though I say it's going to run interactively, but in reality, the bash we use is an interactive shell. The script you use may not be interactive. Options are available which can modify the behavior of the shell started, and you can see on the UNIX shells by example in page 951 there are a series of those options. With the -no-rc or --no-rc option, the .bash rc files will not be read to set the environment variables. Now, the good thing there is you may have things that are being set that you don't want set in specific shells, so that's something to keep in mind. So how do I create a shell? Well, you're going to stick commands, programming construction, comments in shells. The script has to have permissions modified in order to run, so it won't run with a 644. It has to have the execute permission set 7 something something. If you want it open to everyone, user group and other, 755, where the group and the other can't write to the file, would be perfect. One way to build a script is to build blocks of functionalities which you test and then assemble those blocks together into a complete package and then test them again as a complete package. Comments in shell scripts are always appreciated. Comment to a fault. Use comments everywhere. If you're starting a new piece of a shell, use comments, big time comments. Let's take a look at this pp underbar test for grins. Not a thing in it, really. Let's take a look at this tellme.shell. R1, right? Okay. So basically here I've got a bin bash, script name, tellme, and it uses an old style test command. And then it basically goes through and looks at a number of things here. But if I were to go back and look at some of the shells that I've created, every time I start a new segment of constructs, if I'm looking for a particular thing at a certain segment, I'll make sure that there's a big comment above it saying this is what I'm attempting to do with this construct. If I'm mentioning bits and pieces about what's going on inside that construct, I'll have a single line comment. Other times I may have a 5-line comment with a header line, a space line, a line that has the info on it I want, another space line, and then a trailer line. So let me show you what I'm basically talking about. So if I wanted to do that, I would do, let me do this. I'd comment, run a comment again, comment. This block is to test new functionality. Let's test file existence. How about that? Then that. This makes it very easy for someone to see what's going going on. So let's get out of this. Yep. Escape. Q. Get out of there. Okay. Comment to a fault again. It's like voting in Chicago. Comment early and often. Yeah, and that's the first piece there. Comment lines start with a hashtag. When you need to attract special attention, you can use dashes or pluses. Comment lines made of special characters make good demarcations for sections of script, so use that. Now, when we get back, part 2, we'll start talking about reading user input. And this is the end of part 1 of week 13 of cis204 Unix shell scripting and utilities.